packages and circulated among electronic designers of his laboratory. He has vast experience in conducting ground resonance testing of full-scale airborne vehicle, structural load testing, model testing. He has received a Lab Technology Group Award in the year of 2008, Lab Scientist of the Year Award for the year 2010, Agni Group Award for the Excellence in Self-Reliance for the year 2014, Agni Group Award for Excellence in Self-Reliance for the year 2016, DRDO Group Award for Performance Excellence for the year 2016, and RCA Technology Group Award for the year 2018. He has 15 publications, out of which 2 are related to the present work. MEA. So this is the brief biodata of P. Anil Kumar. Now I am welcoming Anil to this session. I am handovering to you.
Thank you, Prabhakar. I hope I am audible to everybody, audible and visible to everybody, and my presentation also is visible to everybody.
Yes, sir.
Thank you, Prabhakar, and thank you, Samir, for giving me this wonderful opportunity to share my experiences with particularly the faculty members. I understood that it's a faculty development program.
Yes.
The title of my presentation is Solutions for Vibration Problems. So basically, many of you must be getting amazed that why at all we should know about vibration problem, why at all we should solve a vibration problem. The reason behind this, and the reason behind which the vibration problems are becoming inevitable in today's scenario is vibration is something like totally unavoidable phenomena in almost all the disciplines, starting from your day-to-day life. Let us say when you are just simply walking on a road. I am not even taking the example that you are riding a bike. You are simply walking on a road. Even then, your internal body organs will be getting exposed to what is called random vibration. And sometimes people who are traveling in the bus, particularly in the childhood, particularly children, they complain with the problem that they get vomiting when they are particularly traveling in the bus. There is a reason in connection with vibration. So what will happen is in your abdomen, where all the liquids, basically though you are taking solid food or liquid food, whatever it is there, ultimately it gets converted into semi-liquid or liquid, and it will be stored in the certain part of your abdomen for some time before it gets totally digested. So at that point of time, your abdomen will have a certain natural frequency. If that natural frequency, the natural frequency of your abdomen gets coincided with the frequency of excitation that is basically coming from the road on which this bus is traveling, then what will happen? Resonance will come. Resonance is a familiar term which you all must have studied during your schooling, particularly in physics subject. So we all remember a classical example where they mentioned that the soldiers are march fasting on a bridge, and when their march fasting frequency associated with their march fasting phenomena, with the frequency of the bridge gets collapsed due to a popular phenomena that is called resonance. So resonance is the main reason. The natural frequency of your abdomen coincides with the frequency of the excitation or vibration, whatever you call, or disturbance that is getting originated from the road, and which is basically getting propagated from the road to the vehicle to the seat in which you are sitting. Finally, it reaches your abdomen and it excites your abdomen with uncontrolled amplitude. It literally shakes your abdomen, though you are not feeling it physically. It shakes your abdomen, which makes the liquid to come out of your body. That is what is called vomiting. So that's a very layman example. And starting from there, you consider 3 popular fields like industrial, where you are thinking about, let us say, a power plant where a pump is running. So that pump also experiences vibration. And coming to automotive sector, whether it is a two-wheeler, four-wheeler, whatever it is, whether it is a tractor, bike, car, whatever it is, every vehicle gets vibration due to the road roughness, and apart from that, speed of the offers vibration. And further, when you get into airborne applications, starting from helicopter, aircraft in which you are traveling, and you take any supersonic or hypersonic vehicles, they also experience vibration due to aerodynamic pressure, thrust, and due to other disturbing sources. So vibration is something like COVID-19, I can say, in the today's scenario, with which you have to live with, while finding a problem for the vibration problem, so as that vibration will not affect you or your system not to function. So in today's scenario, finding out the solutions for vibration problems is really a I can say exciting topic, because the beauty of vibration is finding out a solution for vibration problem is not that easy. Normally, during summer season, whenever we are experiencing high amount of heat, when you are staying in your own home, you have a simple technique called cooling cement. That cooling cement you apply onto the roof of your building, and then you get away from the heat. So it is not that easy to come out of the vibration problem. Practically, finding out a solution for vibration problem is a tedious task. And apart from that, another, basically I'm using positive words. Another beauty of vibration is a solution which is found for a particular problem. What I mean to say, a solution found for a pump. Let us say pump is there, pump is experiencing vibration problem. You have found out, you have evolved a solution, and there is no guarantee that that solution works for another pump. That is the beauty, that is the unique feature of vibration. Solution for a particular problem is very unique, and it is case specific. So depending upon the case, you have to evolve the solution. So that is why solutions becomes interesting kind of thing, I can say. So I am basically working as a scientist in a research center that is DRDO laboratory, which is situated in Hyderabad. So getting into the topic, we need to understand basically what is the philosophy that we adopt for vibration control. There are actually three possible contributors, starting from the source. Source, what I mean to say, I take the example of automobile vehicle. Let it be a bus. When it is going on the road, the waviness of the road will offer some kind of vibration. And many people think that road roughness is the main contributor. In fact, during our course of application, during our when we are dealing with vibration problems, what we understood is more than the road roughness, speed with which the vehicle travels is the main contributor. We can say major contributor towards offering the vibration to a particular vehicle. So that is basically called source. And second thing is path. Path is connecting link between source and system. Suppose if you take the automobile vehicle, tire becomes the path. Source is the road roughness, system is your bus, path is the tire. Tire, you can say, that is the path. And then system is your bus itself. Let us say bus body or the seat in which you are sitting. And then response. Response is the final parameter, what is the creating problem to you. So basically, when you are thinking of controlling a vibration, so the three possible areas where you can focus to reduce vibration is source. So you can attempt for reducing the excitation at the source itself, which is practically, I can say, almost impossible. You can't tell road that you be smooth all the time so that I will not experience vibration. You can't do that. That is practically almost impossible. So the second option, possible option, what is there in your hand is try to alter the path, try to alter the design of the path so that whatever the vibration energy that is coming from the source, in the process of getting transferred or propagated to the system, it gets reduced, it gets attenuated. In the field of vibration, reduction is called attenuation. attenuation standard nomenclature in vibration. And further, what you can do, you can think of modifying the system, because systems design will be in our control. So this is the basic vibration control philosophy. There are actually 3 contributors. First one is source, which is practically difficult to handle. Second one is the path. You try to modify the path. And third one is the system. You try to modify the system. So I just want to give a layman example here. See, normally people travel in different types of buses. Let us take the example of bus. In our let us take the example of Warangal. When you have to travel from Kajipet railway station to your engineering college or anywhere, you will be depending upon city buses, that local city buses. Do you afford to travel in such kind of that 1 number or 3 number, that the local city bus? Do you afford to travel in such kind of bus from Warangal to Bangalore? You don't prefer, because for such kind of long journey, you opt for a Volvo kind of vehicle. What is the difference between ordinary city bus that gets roaming, that keeps moving in Warangal, and the Volvo bus? Or let us take some other bus which is having a very good, what do we say, bench type of vehicle. Let us say bench type of vehicle. All these Volvo and then today's private travels vehicles, they are actually getting from the bench. So we need to understand why we cannot afford to travel in an ordinary city bus from Warangal to Bangalore. When we are able to travel, I am not talking about money part. I am talking in terms of comfort. I am not even talking in terms of that air conditioned weather and all that kind of good kind of ambience that what prevails in the bus. I am totally talking about the comfort with respect to vibration. When you are traveling in the ordinary bus, you experience more vibration. When you are traveling in the bench type of bus or Volvo bus, you almost experience no vibration. You experience almost no vibration. What is the difference? That difference we need to understand. And why we cannot? See, we so many of us are engineers. We are very good mechanical engineers. We know very good. We have very good understanding and subject knowledge about the vibration. But still, why we are unable to improve the ordinary local city bus to the extent of so-called Volvo bus? That we need to understand. The primary difference between an ordinary bus and Volvo bus is the suspension system. In an ordinary bus, if you see the suspension system, either it will be made up of leaf spring or a coil spring. That's all. Some kind of damper will be there. When you go to the Volvo or bench type of vehicle, the suspension what they use is air suspension system, pneumatic suspension system, that offers more comfort. So we often feel that the suspension system what they are using for Volvo vehicle or bench vehicle may be highly expensive. That much money we are unable to afford for a normal ordinary bus. That is why we are forced to depend upon a poor suspension system. This is what we think. But the fundamental difference between suspension system that is being used for ordinary bus and the suspension system what is being used for pneumatic or Volvo bus is just zero, just nothing. You can, if you want, you can improve the suspension system design of a ordinary bus also without spending